Monday, February 10th. I'm Adam Walsh, and this is The Signal. So we are just out of the warmest January ever recorded. Today on the show, we talk about what that means, then dive deeper into a discussion about the ocean and climate change from above the water to deep below. So for those of you in and around St. John's Metro, it's a storm day. The rest of the province, not so much from what I heard in the morning news meeting today. But for, all of you who are snowbound, we still have a show for you. We made it in, and two guests made it in here too. It's fantastic. I thought the whole show would be by phone, but these are passionate people I have here in the studio today. So we're talking climate change, right? What you should know about the ocean and climate change. Obviously, we're not going to cover everything in 55 minutes because there's just way too much to talk about. But like I just mentioned, from off-the-chart sea surface temperatures to risks to marine ecosystems and species, we will talk today about what we know is happening, what we're trying to figure out, and we'll talk projections for low and high carbon futures and also what that means. As you're listening to us, The Signal at cbc.ca for your thoughts or questions today. So the email line is open, The Signal at cbc.ca. Here with me in studio, we've got Joel Finnis, Memorial University climatologist, Frédéric Cyr, research scientist at the Fisheries and Marine Institute, and Tyler Eddy is on the line, research scientist as well at the Fisheries and Marine Institute. Thanks for joining us. How you doing, guys?
Good. Good morning. Thank you.
All right.
Yeah, thank you.
So it's winter 2025. I'm going to ask each of you this. What's it like working in the climate space in this point in time in history of the winter of 2025 or just around now? Joel, we'll start with you.
Sure. So I mean, there's obviously it's a busy space to be working in at the moment.
Yeah.
You've got a number of large scale climate related challenges showing up in North America. Of course, on the other coast of the continent, we've got out of control wildfires impacting one of the major cities in North America. On this coast, we're dealing with a very warm winter. As I know it doesn't feel like it today, but up to this point, you know that we haven't been shoveling much. And this is coming off the back of a November where we got more than twice as much rain as we normally would, raining regularly, basically every day in the month. So yeah, it feels busy as we're trying to make sense of how quickly climate change is progressing and what kinds of challenges and risks we're going to be facing in the short term and even into the longer term.
Fred, what about yourself?
It's a good question. Actually, I asked myself the same question to my climatology professor back in 2007, I think. And I said, it must be depressing working in the world of climate as a researcher today. And that was, years ago. And he answered me, well, yes, but also as a scientist, it's a very challenging time, an interesting time to be working in the field. So I would answer the same thing. Basically, it's very interesting from a scientific perspective, although it is a bit scary what's going on right now.
Yeah, it's one of those things that if it's the time to be working in it with everything going on. Like it's one of those times where it's like, wow, like the work is it's always been important, but like now it is just so
it's
important.
Fun to be part of the conversation and part of the research as well.
Tyler, what about yourself?
Yeah, so similar to the other gentleman, I think, there's a lot of doom and gloom out there, and with, good cause. I mean, a lot of what we're seeing in science is alarming. But, something that I try to highlight when I'm talking to folks or students especially is to, try to prevent them from becoming overly pessimistic is also if we look at the technology and, the energy space, battery power, we're making way more progress in a lot of these fields and technologies than we expected, 10 or 15 years ago. So while we are seeing a lot of negative impacts, I think part of the silver lining is a lot of the projections about how quickly we could transition off of fossil fuels. I think we've, exceeded what people thought was possible. So I think that, there is a lot of opportunity at present times as well.
Yeah, I find for hosting this show, I try to strike a balance. Like we've done Climate Week a couple times now in the fall. We'll do it again. The plan is, anyways, to do it again this fall. And in those weeks, I try to kind of have folks who are working towards optimism, who are working in this space and trying to make a difference on the climate file. And at the same time, I try to talk about, well, hey, like Joel, you mentioned what happened in LA, right? We talk about the warmest January ever on record. So it's this balance of like seeking folks who are doing the work and talking about some of those great things that are done. And there's a book that we were talking about just in the lead up to the show that I'm trying to order. What If We Get It Right by Ayanna Elizabeth Johnson, and who's big on the climate file, and that is quite an optimistic type of a thought process on it. I promised at the beginning to talk about January. Joel, I'm looking at you. Why was it so? Because I thought it was supposed to be colder, not just because it's January and winter, but why? Like in comparison to others, it's the warmest recorded on record. What happened? Because I thought La Nina was supposed to take care of this. And that's the extent of my knowledge, by the way.
No, in terms of global temperatures, yeah, La Nina will tend to drag down sea surface temperatures in the Pacific, right? So that would act to pull global temperatures down as it produces unusually cold temperatures. This is all just tied to wind flows off of South America and how it encourages upwelling. But that comes off of the back of a strong El Nino rather, the year before, which does the opposite, warms things up. But of course, this comes along too with other impacts. When you start messing around with ocean temperatures like this and you create large anomalies, you end up shifting preferred paths of storms and the characteristics of those storms when they pass through various areas. So, for example, La Nina will have helped to decrease overall global temperatures, but obviously other things are happening that are cranking that up and offsetting it. And, I mean, we're certainly the La Nina event has helped to encourage the dry conditions that have fed the LA fires. But over here, something else has been happening over the last couple of years, and it's not connected to El Nino or La Nina. It's happening in the North Atlantic. And in many ways, it is very surprising to see. But average sea surface temperatures in the North Atlantic have been really what I would describe as like 15 years ago, we would have thought of them as unthinkably high, right? It's the kind of abrupt shift that we've seen a couple of times in response to climate change. In this case, it's sea surface temperatures. The other one that really sticks out for me as a climate scientist that spent a lot of time thinking about the Arctic was in 2007 when we saw an abrupt decline in sea ice extent. That really marked a loss of volume that the Arctic hasn't recovered from. And we've sort of seen since then other record minima sea ice extents. And so it's a sign often when you see those sudden shifts where sea ice loss is decades ahead of what it's supposed to be, or the sea surface temperature changes seem to have suddenly surged forward. It's a sign that climate is going to continue to surprise us. It's a reminder that we don't fully understand everything that's going to come out of climate change, and that, again, some of those surprises are going to cost us in some ways, right? They're going to bring knock-on effects that we're going to have to learn to deal with.
So what do we need to keep doing we know the temperatures are up. I have three of you here. How do we look at the impact of that and what it means for weather or on the surface and then deep below?
Well, the two events that Joel just mentioned, decrease in sea ice and increase in sea surface temperature may not be independent to each other. Sea ice is melting; it creates more fresh water in the North Atlantic because the Arctic is melting, and same thing with Greenland. And this will stratify the ocean like a cake, basically. And so, having in 2023, for example, there was also off the chart sea surface temperature, and we, with a few colleagues, we were working on a study where we show that basically it is the fresh water in the system that actually make the top layer so thin that it could accumulate heat in a much thinner volume. So this is why it was much higher, and it was not mixed basically down below. The change in sea ice may influence the sea surface temperature, and so all these things are interlinked.
What do you think people don't understand then, or can you explain a bit more about the temperature difference from the surface to below?
Yeah, so in the region here, especially because we're so close to the Arctic and to very cold winter conditions, in the winter, in a normal winter where it's cold, actually, you generate a very thick layer close to freezing point. We're talking about close to -2 degrees Celsius. And so when the spring arrives, there's a new layer that appears on top that will get heated by the sun, but that very cold winter layer would stay under the surface, under 50 meter, 150 feet. This layer will stay there all summer long. So in the middle of the summer, if you go anywhere on the Newfoundland Labrador shelf, at 100 meter, you'll find water below zero. And so this is the dynamic. The warm January we had will impact the bottom temperature or the deep temperature next summer. And this is how we understand the ocean.
Okay, well, thanks for that. So what does this mean for species then? And should I bring Tyler into this part of the conversation?
Sure. Yeah. So, I work more on the biological side of things. So how, the changing temperature and the sea ice affects, everything from the plankton up to cod and snow crab and things that we eat and fish. And we know that, species have temperature preferences. Snow crab likes colder temperatures. Atlantic cod tends to like warmer temperatures. So we know as these temperatures change, they're going to affect the distribution of where the species are found. And then it also can affect the productivity of individual species. So one thing that we've noticed in some of our studies is that snow crab catches have been declining in the past decade or so. And we've done some climate change projections saying, okay, based on the work that Joel does looking at sea bottom temperature under these different carbon emission scenarios, we're actually expecting that the temperatures are not going to be favorable for snow crab in the future. So we're actually expecting their biomass to decline. On the other side of things, cod prefer those, warmer temperatures up around 5 or 6 degrees Celsius bottom temperature. So we're actually expecting the environmental conditions to become more favorable for cod. And so it's one kind of step in order to make these projections using just temperature, but we also know that there's a whole food web out there where, cod are eating different things are eating cod. So it basically kind of reshuffles the deck of all of these different, food web feeding interactions that we have in the system. And so, some of these unexpected consequences that Joel mentioned before, we have to kind of be humble to the fact that, there are going to be these sort of novel ecosystems. There's going to be new species overlapping that perhaps haven't overlapped historically. So that's one of the real challenges that we see. But in general, we're going to see shifting distributions, and there'll be some winners and there'll be some losers.
Yeah, it's the same as when we hear about some of the lobster story, right? Like there's lobster further north than they've seen before. So is that like that? That's part of it as well, I guess. Is that them moving because of temperature, or is that something you know about?
Yeah, so that's definitely another observation. And lobster prefer warmer temperatures. So I'm from Southwest Nova Scotia, which is lobster territory, and it's been booming there for years. And as the temperatures warm, we're starting to see that distribution move farther north into the west coast and the south coast of Newfoundland, where they're having record catches. So that's definitely related to the shifting environmental conditions.
So, guys, what does it take for this conversation we're having now, talking about all the research you're doing, talking in some extent to what could happen to snow crab, the biomass for cod? By year 2100, by the way, there's a CBC article on that from November. Climate change makes winners and losers out of cod and snow crab, says scientists. So if you do want to read more on that, just search it online. You can find it. Where do we get all this information from? How do we is it observations? How does it all happen, guys?
We have complementary skills, right?
Exactly.
So, yeah.
It's almost like there's a reason why you're all here. So let's map this out. How does it start, and then who complements one another, and where does that all go?
Well, I mean, it doesn't really start one place or another, right? They're constantly feeding off of each other. If I think about the history of climate modeling, it has fed the Earth observation efforts where people are trying to collect more information. The modeling tells us sometimes what we can look at and where we need more information. And the observations help us figure out whether the models are working. So there's been this back and forth continually. And of course, sometimes there's more investment in one area than another. But basically, those observation and modeling efforts have progressed hand in hand for decades now.
So then talk about, so what does it take for for the modeling you do? Like where does the info come from? What does it take to do modeling?
Well, I mean, more and more what I spend my time doing with models is not running them, but instead making sense of how they all fit together and the bigger stories that they tell. I would say that, this is not to besmirch anybody's particular area, but we've spent so much time running models, and relative to the volume of information we've generated, relatively little time sitting down and trying to put it all together. So we do that collectively. That feeds into things like the IPCC reports, the Intergovernmental Panel on Climate Change reports that we get every couple of years. But still, I mean, by the time you start putting that report together, the next iteration of model runs with the latest generation of models are already underway. And we barely scratch the surface sometimes of making sense of how they all fit together. And I think that there's value in digging into this more and more, particularly as if you're working at a modeling center, you've generated a new model, you're looking to validate it. There's a tendency for those modeling centers to say, well, okay, if my model doesn't match what all the others are doing, I'm a little bit worried that it's going nuts. It's going haywire. It's not in line with all the others. So let me tweak it and adjust it until it does match what the others project. Which means we end up discounting, in a lot of cases, the more extreme outcomes. The modeling centers themselves are understandably, given the amount of scrutiny that climate science receives from the general public and from the climate skeptic community, there's a tendency for us to tamp down our more extreme projections.
So is this perhaps why you'll get projections that just get surpassed, and it happens so often?
It's absolutely 100% part of it, right?
Yeah.
And even the last generation of runs for the last IPCC report, there was a tendency for people to say, well, okay, this handful of models are what we're calling hot models. They have projected a bigger shift in response to carbon change than the other models. There's a lot of people who recommend that we discount those. And I would sort of argue instead, no, there's got to be valuable information in here. And making sense of why they go haywire and where they go haywire, but also how it matches some of the extremes that we might be seeing later on is a really incredibly important piece of the overall climate projection endeavor, let's call it.
All right. And Fred, for yourself, I mean, you were doing observations for years with DFO plus other work. Tell us about that.
Yeah, so my work is what I call, I like to call contemporary climate change. So basically what's happening now and in relationship to what happened in the last few decades. And this is something I've done for DFO for the last 8 years now before joining the Marine Institute. And it's quite important. Regarding the ocean, DFO has this wonderful program that is called the Atlantic Zone Monitoring Program that was created in the 90s, just after the collapse of the groundfish, because the collapse happened during a very cold period of the early 90s. And at the time, there was this question, is that overfishing or is that changing environmental conditions? And the answer is probably a mix of both. But there was this committee put in place to basically try to improve our knowledge on ocean conditions. And so this program, Atlantic Zone Monitoring Program, or AZMP, was created not only here in Newfoundland, Labrador, but also in Quebec, in Nova Scotia, the entire New Brunswick, all the Atlantic Canada. And so we go at sea, collect data, both physical, plankton data, biological, chemical data. And the idea is to understand the changes undergoing by the ocean as they happen. And so a lot of this information is further used into the models, whether for tweak the models to see how well they fit reality, but also just to improve weather forecast. A lot of this information is going real time in international data center. And this information is further used to improve the weather forecast, such as storm, for example.
Right on. And Tyler, what about yourself, or your work and how you fit in with it? Like kind of piecing out the work that each of you does and how it kind of fits together.
Yeah, so I think, like Joel said, the two go hand in hand.
Yeah.
And, we can't really improve our models unless we have observations to kind of constrain them. And so, one thing that we've done in some of the fisheries and marine ecosystem models that I work in is we look, during historical events. So there was a, heat wave in Europe in 2004. It killed 500,000 people. had major impacts on the agricultural food production systems, on the fisheries, huge kind of shock to the system. So we actually go through our model runs where we have that heat wave represented in the model runs, and then we look to see the impacts that our models predicted, and then we compare that to the actual impacts that were observed, and we can use that as kind of a skill assessment test to see, okay, are our models overestimating or underestimating these impacts? And that kind of gets at that question that Joel was talking about, whether or not we're representing these extremes well enough. And the result of that study was we found that for a lot of these different impacts, the models underrepresented some of these observed impacts. So yeah, the two go hand in hand. And as modelers, we're always hungry for more data. So like people like Fred who are able to go out there and provide us with these observations, it's worth gold as far as I'm concerned.
Yeah. What? So this only came in the net. Like the specific one you're talking about, Fred, only came in the '90s, right? Like what would happen if those stop? If all of a sudden there's no that gold's not being handed off to some of the other scientists
Yeah, I mean, I must say that there was some observation before,
yeah.
but it was not a integrated program with a regular, regular procedures and seasonal coverage, etc. But if this would stop, that would be a big hole in the data and in our understanding of the system. This really, the ASNP really created a system to better understand not only what's going on here, but at the scale of the North Atlantic with different partners. We collaborate on that, and we exchange information to a level that was not possible before. And that really pushed forward our understanding. And especially disentangling also the climate change linked to human activity and the natural climate change undergoing by the system. Because where we are right now with the connection with the Arctic, our system is also changing due to natural, there's natural cycles. There are some cold years, some warm years, and it's usually, these cycles are usually pretty slow. Like we're talking about a few, tens of years before changing to a cold phase to a warm phase. And so going there and measuring some of the metrics every year is very important to understand this and to disentangle the natural climate change to anthropogenic climate change.
So what types of things do you measure when you're out there?
We go on ships and we measure, of course, temperature, salinity, not only at surface, but all the way down to the seafloor. We measure all kind of nutrients, also the phytoplankton and zooplankton, so the little bugs that is at the base of the food chain. And so that you really kind of bring the energy of the sun into the ocean, and all the fish then will eat those little bugs. And we, on top of that, we also monitor sea surface temperature with the use of satellites. But going on the ocean and putting instrument below water, that's quite important as well.
Yeah. All right. Cool. Because I wasn't sure, because I knew there was observations that happened, but I wasn't sure exactly what was being observed. So,
and other stuff we do as well. You might have heard in the news the AMOC, so the Atlantic Meridional Overturning Circulation, which is what they call the Great Conveyor Belt of heat and salinity. We hear scenarios where what if the Gulf Stream slows down, whatever. This is all interlinked, but this is also we also monitor these changes with what we call mooring. So we put instrument in the water that measure basically the currents, and we leave them for 2 years, and then we recover them and we analyze. So there's this big program called OSNAP. It's for the overturning in the North Atlantic, subpolar North Atlantic, and there's a series of mooring with many countries involved, the U.S., England, Holland, Germany, and we have a series of mooring all across the Atlantic, and we can measure this AMOC that I mentioned and how it is changing, and is it true that it's slowing down or not?
So is it true?
There's a lot of variability. So it has shut down in the past, and right now there's there's more natural changes than a clear decline. But it's definitely something that we're interested to look at, because some models are projecting this to actually almost shut down in the next century.
What would that mean?
That would mean less export of heat from the tropic to the north. So that would cool down. Actually,
Europe's in trouble, right?
yeah,
Yeah.
It would cool down Europe quite a bit.
Yeah.
And then at the tropic would be much warmer, because this whole like conveyor belt brings a lot of heat from the tropic and keep the northern area mild.
Yes, because I've seen that in the news. I was wondering about it, and with you here, I was like, I figure I'll ask. So it's still monitoring it, seeing what will happen.
Yes,
Okay.
we are still doing it.
When we talk low carbon future or higher carbon, can Joel, perhaps could we start with you on this? Like when we're looking at where we are right now, and everyone's talking, like the big talk has been in recent years, it's like 1.5 degrees, Paris, the agreement that was made, and whether we overshoot it, where we're going to be. And then we start hearing about, well, here's what could happen when it comes to climate and any other type, like from I guess weather, climate, what impacts to folks, depending on if there's more carbon in the environment or less. Can you talk a bit about the differences?
Yeah, absolutely. So I mean, the idea behind these things they call carbon budgets these days, right? Yeah. It's a measure of how much carbon we can still consume, we can still use, we can still burn before we end up increasing the chance of crossing these temperature thresholds. And we've collectively, globally, made a commitment to keeping us below 1.5 above pre-industrial levels, 1.5 degrees Celsius above pre-industrial levels. So you have a sense of how much oil, coal, et cetera, we would be able to burn before we get to a point where we think there's a 50% chance we'd exceed that. I think we've seen a lot of action taken to curb carbon emissions over the last couple of decades. We're not meeting the commitments that we've laid out yet globally. But, I mean, honestly, the landscape is changing a lot, right? We've got a new administration in the States.
I've heard about this.
You may have seen it in the news.
I kind of, it's hard to find, but I did manage to catch it.
So they've again backed out of that agreement. But it seems like maybe they're less of an important player than they were a few years ago. They're still one of the major emitters in the world. But if you take a look at a place like China, they're actually rapidly curbing their emissions and really leaning into renewables. So last year, if we were still all keeping to our commitments, last year could have been the year that we peaked with carbon emissions. It had almost plateaued as of last year. And again, most of that's not due to what Canada and the US and Europe are doing, although those countries have all been helping. It was really a huge outcome of the major changes that China had been making. I think about countries that back out of these climate agreements now and lean back into fossil fuel consumption, and I think, they're going to get left behind, right? They're taking themselves out of the kind of technological discussions that other countries in the world will be pushing along. It seems to me like a losing strategy. But what this means for the future is that if we are actually collectively reducing our carbon emissions, the worst case scenarios, the highest carbon futures, probably become less likely. I don't have to necessarily take a look at what's going to come out of the 100-year projection from the highest carbon scenario, a possible future where we just keep burning fossil fuels like we have been. I can say that those outcomes are probably less likely in the long term. In the short term, though, I have to think about how observations, and this is, again, much more, there's more variables, there's more dimensions to how climate change impacts observed to this point match various different climate scenarios. But I have to pay attention to that. And as Tyler pointed out, there's indications that we're still kind of ahead of schedule of even the most pessimistic climate scenarios. So in the short term, I have to emphasize those. But the optimistic story here is probably I don't have to think about the worst case scenarios for the end of the century. Those have become less plausible than they were a few years ago. But still, trying to figure out those two dimensions of plausibility as we try to map out what future we're actually following gets really complex, right? Yeah. Do the sea surface temperatures match what the models say? Does the sea ice? Does average surface temperatures? Do the kinds of extremes that we're seeing match one scenario or another better? In the short term, probably focus on those high carbon scenarios. In the longer term, maybe we're avoiding those cases if we continue on the carbon reductions we've seen so far.
Tyler, can you talk a bit about confidence when it comes to modeling and some of the work that you're doing then, and just how difficult it can be to have confidence on in this neck of the woods for Newfoundland and Labrador?
Yeah, so as Fred mentioned, it's a highly dynamic system that we
Yeah.
have here naturally before you add, anthropogenic climate change on top of that. So we know that, there are dramatic shifts that we've seen on these, 10-year decadal timescales that Fred was mentioning. So I think that we already have a challenging system, by default. And then so we add on climate change and we try to tease out, the effect of climate change compared to the natural variability in the system. So I think, that's already a challenge that we have. And if we're thinking about trying to manage resources such as, snow crab and cod and lobster, where these things, they're changing in their abundance over time. So trying to think about, how we manage them sustainably, it's really important to try to keep track of, what the productivity of the system is doing and what that means for the individual species. So then when we think about confidence, so one approach that we use in order to try to get an idea, because of all this complexity that Joel has mentioned with all the variables that we're trying to represent within the models, often the one approach that we've used, and this is an approach that's been championed by the IPCC, is we look at a range of different model projections. So, Joel might be working on one specific model. There might be another group in France that's working on a model, groups in the US. And so then we have all the different projections from these different models. And in general, they're kind of trying to do the same thing, but there's kind of subtleties within how they might represent, specific processes within these models. And so some might be better at predicting sea surface temperature, some might be better at predicting sea bottom temperature. But then the idea is that we look at a range of what the models are saying, and we see whether or not there's high agreement in what projections they have for sea surface temperature or for pH, for example. And one thing we notice is the projections for pH globally are very tight. So there's not a lot of variability based on which model you look at. So we'd say those are relatively high confidence, whereas other variables such as sea surface temperature or net primary productivity, which is kind of a representation of the bottom of the food chain, we see a lot more variability there. So there's kind of a lower amount of confidence that we might have in any one of those individual projections. So that's why we kind of try to look at the range from the high and the low of what the models are saying, the hot models versus the cold models. And then we come up with this kind of a range of variability so that we can have an idea of what the projection might say. So that's kind of the general approach. But yeah, it means that we have to look at a wide range of models, and it makes things more complicated. But I think it's kind of the best practice to approach that.
Well, like that report you sent me, climate risks projected to affect fish biomass around the world's ocean, right? FAO report says fish biomass faces steep falls by end of century under high emissions scenario. So this was, I guess, October last year out of Rome. And by end of the century under the high emissions scenario, which projects global warming of 3 to 4 degrees, declines worsen to 30% or greater in like 48 countries and territories. But in the low emission scenario, 1.5 to 2 degrees, changes stabilize between no change and a decrease of 10% or less across 178 countries. So just it gives folks a range of what can happen depending on how much carbon is still put out into the air.
Yeah, and I guess the general finding is, with more climate change, there's greater risks. So that's kind of the rationale for trying to minimize the amount of carbon emissions that we're putting out there.
Folks, you're listening to The Signal. I'm Adam Walsh. Today we're talking about climate change. We're just off of the warmest January ever recorded. So we're talking about climate change today on the show, about the ocean and climate change, everything from off-the-chart sea surface temperatures to risks to marine ecosystems and species. We'll cover what we know is happening. We're talking about what we're trying to figure out, and we're talking projections for low and high carbon futures. If you've got thoughts for us today, thesignal@cbc.ca is the email. With me here in the studio, Frédéric Cyr, a research scientist at the Fisheries and Marine Institute, Joel Finnis, Memorial University climatologist, and on the line, Tyler Eddy, a research scientist at the Fisheries and Marine Institute. So how hard is it communicating all of this to folks, guys?
Well, listen, you got to start talking about confidence and probabilities and things like this. It starts getting kind of messy, right? So as soon as you're dealing with confidence, what you're really talking about is a measure of uncertainty. And of course, the general public sometimes hears confidence and uncertainty as, well, they don't know what they're talking about. When really, my job as a scientist is always to make an educated guess and quantify how confident I am in that, right? So my entire job isn't to tell you how the world works. It's to propose it and then say, and this is my level of uncertainty. That's how science has always worked. But of course, if people are looking for definitive answers and expect that, particularly when we're talking about something like climate change projections, where we're thinking about what's going to happen 100 years in the future, that's got to come with some uncertainty. And so we can take a look at what's been going on here. And I often think about how the discussions have shifted in my time from being an undergraduate to a PhD student to working in this now for 15 years at Memorial University alone. And I would say that we keep moving into bigger and bigger spaces of uncertainty and more surprises, right? So I think that's a shift in the kinds of discussion. I used to have discussions about climate change, and I'd be like, I think we're probably going to have this under control. And it eventually gets to a point where you're like, well, it's getting harder and harder to get this under control. And, as was mentioned, as the world gets warmer and warmer and warmer, our ability to anticipate what that means, because it's moved so far away from what we've experienced and observed up to this point, it comes with more and more uncertainty, right? So the more we constrain climate change, the more we get it under control, the less change that we end up producing, the more confidence we have in our estimates of what's going to happen. The less we constrain it, the more we kind of have to shrug our shoulders and say, well, yeah, this is my best guess, but honestly, it could go absolutely haywire from here. We just don't know, right?
So when one of the IPCC reports, whenever they do COP or like a report comes out, how many people, and we've talked about this on the show before, but just give folks an idea of just how much work goes, because when we talk about projections and confidence and where things are going, how much work goes into this stuff from scientists all around the world?
I mean, this is thousands of scientists, right? I mean, this is an insane research effort, and it's probably the biggest sustained scientific endeavor in terms of manpower and just like effort that I can think of. I can't think of anything else that's been this concentrated and prolonged, right? I mean, decades now of trying to make sense of this.
Yep.
So then your conversations, right? There's the conversations you have with colleagues or as professors, then the general public or people in your orbits. How have you seen those change over the years?
Well, social media has changed a lot of things, of course.
It's all been great.
Yeah, yeah. I mean, it becomes easier to reach people.
Yeah.
The problem is the quality of information sometimes is being degraded as a lot of misinformation going on.
Yeah.
So I find it difficult as a scientist sometimes. You cannot start chasing misinformation. That's not my job to do that. My job is to provide the best information possible. But sometimes it breaks my heart to see so much misinformation going on. So to answer your question about communication, I think doing our best, that's something we can do. And for the general public is just to seek good source of information. I think that's the key here. And again, there are uncertainties in what we do. But our job is also to make some calls and to say that, well, this is important, this is very likely, so I think this is important.
Tyler, what about yourself?
Yeah, that's an interesting question. And so I guess the general trend I've noticed is, more of a kind of questioning of climate change. And when I used to teach undergrad, I used to teach a second year introductory biology class at Dalhousie University to 200 students. And the two things that I would really try to drill into their brain were, why climate change is real, and here's the science, and here's how you can explain it to someone if they don't believe you, and then why vaccines are so important and the impact that they've had on human disease. That was pre-COVID, but it's been interesting how that kind of played out. And so I guess COVID was also an interesting experiment where, we had to develop this vaccine. We did it at, record pace, but there was a huge amount of, misinformation and distrust of, the scientific community. And I remember chatting to people, and people, I'd say that I was a scientist, and I would be kind of looked at as if I was, a used car salesman or a lawyer or something, as if it was like this disreputable line of work, which was, really kind of shocking for me. And so, like during those hard conversations of COVID, when there was a lot of uncertainty, there was a lot of, everyone was kind of afraid. I was trying to develop different communication techniques of, trying to reach out to people and make my point of why we should trust the science.
Mm.
And one thing that I noticed is that if I kind of tried to demonstrate or make like a human connection just on a personal level first about something non-scientific related, and that you build that sort of level of baseline trust, after that point, I felt like I had more effectiveness of trying to say, okay, this is what I do. Do you trust me? Do you believe, what I'm saying? And if you've kind of established that relationship of trust, then I think there's more of an acceptance of maybe the science that you do. So that was kind of an interesting observation for me. But yeah, it's challenging these days with the amount of stuff that's out there, and some of the world leaders that are not necessarily sticking to what the scientific evidence tells us. So
Mm.
yeah, I don't really have any
No,
clear
I think that's a great
solutions.
answer. No, I think I love I do really enjoy hearing about how some folks like yourselves interact with people, right? And those conversations, because I know how I interact with people. Sometimes I can be at a social event and folks are talking about the news, and I'm just in my head, I'm like, nope, that's not accurate. And sometimes I engage, and other times I don't, because you don't want to be the fact checker at a party the whole time, right? Because no one likes that person.
I think, Tyler does get to an interesting
Yeah.
point, right? I mean, building a degree of human relationships with
Yes.
the people that you're communicating with is important. As somebody in a university classroom, we get the opportunity to do that a lot. But also, I think about other models of communication and the relationships that get built. And I think about climate communication in particular as something where our colleagues as meteorologists really have an opportunity here. The amount of relationships that those public scientists, really, people doing the most public science, where every day they get out there and say, okay, here's my educated guess at what's going on. This is a sense of the uncertainty, 60% chance of precipitation, to an audience that often gives them a hard time. And like, I wish I could be.
I was going to say, people love meteorologists until they get one wrong, and then it's
we love grumbling about it,
Yeah.
but at the same time, those relationships do matter. And
Massively.
I think about instances like Hurricane Fiona coming to Port aux Basques, and I think about stories that I've heard from both the then mayor of Port aux Basques and meteorologists, where they were calling in and saying, just so you know, like, I know this is serious, I know that you've seen the warnings, but I want to stress that this could be like worse than you're expecting, right? I know you've seen hurricanes. This could be really bad, and that cranked their urgency, their sense of urgency, and their push to get prepared right up. So those kinds of relationships can really make a big deal. That trust is really important, and it's hard to build that trust on social media. But there's other avenues that we can lean into to sort of say, yeah, we're human beings. We care. We have a relationship here. We're trying to help you. We're trying to serve you. We're here to facilitate. And I think that those relationships, when we can build them, are important wherever and however we can.
Yeah, I think part of it is when you're seen as part of a community, right? And when you're out talking and you're doing so. Yes, for the meteorologist, 100%, and also for you folks too. Like if you're seen out in the community, I don't know, like riding bikes around, whatever else. Like it's people feel closer to you that way when you're part of it.
One of my favorite facts for when I chat to people in parties or in public events is the fact that we were able to measure how much carbon we've put in the atmosphere, right?
Yeah.
Currently, the concentration of CO2 is about 420 ppm, so party per million. This is uncharted territory. It's been more than 2 million years that we've been looking the past, and we haven't seen this concentration in the atmosphere. And what I say, people, is that a change between 200 to 300 is what it takes to bring us out of a glacial era. So
Like out of an ice age.
an ice age. Sorry, out of an ice age. 3 kilometers of ice above Canada, basically. So 100 ppm is enough to take us out of that. So from 2 to 300. Now we are above 400. So if 100 ppm can take us out, what 100 ppm on top of that will do for climate. And yeah, this is basically where we are right now. So it's I think it's an interesting perspective to think about it.
It is. And you say you use that at parties.
Well, sometimes try to convince people that climate change is real.
I think it's a very good explanation. We got a note in. All right. Let me see. From a listener, I really appreciate the interview about climate change and ocean climate and how it can impact different species. Like Tyler mentioned, the losers and winners of climate change. I'm very curious about climate change and how it affects aquaculture in the province. Fish in these cases cannot really migrate like fish in the wild. What can we expect? Don't know if anyone here can have an answer to that, but I'll put it out to all three of you, including Tyler, who it was addressed to.
Sure. Yeah. I mean, well, with these rising ocean temperatures and heat waves, especially, there's been documented cases of mass salmon die-offs on the
Yep.
south coast, implicated by, warming waters. So I think, yeah, it kind of relates to the whole trying to manage resources sustainably in a variable environment. So you have to kind of maybe be more prepared for these extremes that historically you would not have had to deal with. So yeah, I think the salmon is sort of the one that has received the most attention. But there's also oysters that are being cultured in Newfoundland and Labrador now, and we're probably better suited there because we have colder waters than a lot of the traditional areas where they're cultured in PEI and Nova Scotia. But yeah, definitely something to keep an eye on. And if you are, a resource manager working in aquaculture, you're going to have to try to be prepared for these extremes that are going to become more extreme and probably more frequent in the future.
What's the balance between trying to be optimistic? We talked about this already in the show, and there's some of the dread out there of where we could go. Then there's some of the optimism, but you don't like. There's also like toxic positivity as well. Like where do you find the balance professionally and like as you kind of march forward with stuff? Like, do you consider yourselves more optimists, or where are you, Fred? What about yourself?
Well, we cannot go back, as I just mentioned. Like we're the amount of carbon we've put in the atmosphere is something that we've never seen before. So we're not going back to. So we have to live with the climate we have. Well, we can mitigate it by reducing our emissions
And adapt to whatever happens.
and adapt to whatever will happen. But the information that we gather will be important to adapt to make the best decisions. Where we build our cities, if the sea level is rising, where if permafrost is melting in the Arctic, all these decisions need serious information and accurate as we can. So this is where the role of climate scientists or oceanographers is helpful, I think.
Yeah. Tyler, what about yourself?
Yeah, I think I'm more on the optimist end of the spectrum, and yeah, I think it's. I mean, a lot of what we do is doom and gloom, and there were times during my PhD when you are doing the science and discovering a lot of these negative impacts that are happening or expecting to happen. But I don't think that pessimism is a great motivator, and I don't think it's great for mental health either. So,
Yeah.
trying to trying to kind of see the positive side of things, and especially when I interact with students, I don't want to just offload all of this stuff onto them, and they walk out of the classroom feeling like there's no hope, because there is a lot of positive success stories out there in this province. We're blessed to have 98% of our energy is renewable energy already. So I mean, there is a lot of positive kind of notes. I think it's just trying to accelerate those things and to give people hope that we do have solutions in hand, and we just need to put energy in those areas.
Joel, what about yourself?
Yeah, so I mean, I would lean into the cautiously optimistic. This is the upside. This is a problem we understand, right? We know what's causing this. We know the problem. We know what to do. The challenge is just getting us to do it, right? So we have made strides. I do worry a little bit, given how slow it has been to ramp up climate action and to start cutting down our emissions. I have to keep that in mind whenever I'm feeling optimistic, but I can see things accelerating. But of course, I do also recognize that there's often pushes for us to decelerate. And as a population, I think we have to really keep the pressure on politicians, decision makers, businesses, cities, how we're designing things, to just make sure that we're thinking about climate change and how to address that at all times. One of the things that I remind people of all the time, and this is not actually a pessimistic statement, it's just a statement of reality. Climate change is going to cost us all something at some point, right? And we can choose to take those costs now to reduce the overall cost into the future. But if we just keep delaying and we just keep putting off the pain, that pain is going to come much faster, much harder than we'd necessarily want to deal with. So yeah, this is an optimistic statement. Ultimately, it's a thing that we have in our control. We have strategies. We know how to deal with this. It's just about accepting that what we've done and how we've lived in the past can't continue if we want to get this problem under control.
Well, which is why through the show we talk about ranges, right? It's like there's different carbon futures in this choose our own adventure book we are calling Earth right now, and some of them not looking too great when it comes to biomass and fish and other things and weather and climate and you name it, and others not as bad, right? Highly not too bad.
Yeah, and again, some of those changes that we make to reduce our carbon footprints, our carbon emissions at the city level, at the individual level, at the provincial level, the federal level, they end up making your life a little bit better. I'll tell you right now, I'm walking on that multi-use path every day to work. It is cleared more than the streets are sometimes.
I saw a picture.
Oh, it's phenomenal.
Because I try to run the lake, and then I saw a picture. I'm like, I need to go and run up there behind Churchill Square because it looked great.
It's great. Yeah. So we introduce these things into the city. You see them used heavily. You see dog walkers. You see the odd cyclist. I see the odd winter cyclist. God bless them, using it as well. I mean, it's you introduce a lot of these changes, and frankly, they make our city a more functional space in ways that make our lives better, right?
Totally agree.
Yeah, such an interesting point, right? To go, we're having this broad, big climate change discussion, talking about the ocean and sea surface temperatures and far below, and mapping projections for the future. But it's like also there's action taken at a community level of a bike path that people can actually go out and enjoy, and there's benefit on that on a number of levels, right? So, great point. As we there's like 2 minutes left here, any work folks are working on that you could talk about, or what does the future hold for when you're the three of you and in your positions?
Good question. For my personal research, one thing I'd like to develop in the region is some kind of metric that can help fisheries management. Everybody knows what is an El Nino. It's just at the end, El Nino is just a metric that we develop to better understand what's going on. I wish we could develop similar metrics for the Atlantic that can be useful to inform fisheries management, for example.
Right, just make sure it's good Newfoundland slang name, though, right? So El Nino, we got to figure something out.
I'll think about that.
That's a good one or whatever. Okay, Tyler, what about yourself?
Just trying to think of clever Bayman names there.
Yeah, exactly. Right. It's like everyone's like searching through.
So yeah, something that I'm excited about is there's a project called Transforming Climate Action, and this is a collaboration between Dalhousie University, Memorial University, Quebec at Rimouski, and Laval University. And we're really trying to understand the carbon cycle in the North Atlantic, the biological carbon pump, and all of these kind of different processes that are represented in the models that we make the projections to understand the carbon budget. And so I have, I'm recruiting 4 PhD students and a postdoc to work on this project. So yeah, it'll be a lot more kind of new science in this field coming out in the next years.
Oh, cool. Well, I will stay in touch with you on that. And Joel, what about yourself?
Very quickly, I'm really excited about more and more research into meteorology, weather forecasting, as a necessary tool for climate preparedness, something to let us know when those surprises arrive and warn us as they arrive.
Excellent. Guys, thank you so much for this conversation on a storm day in St. John's. I really appreciate it.
Thank you very much.
All right, that was Frédéric Cyr, Joel Finnis, and Tyler Eddy here with me in studio. If you've got thoughts for the show, folks, the signal at cbc.ca. Tomorrow on the show, we're going to talk leadership because there's lots of leaders out there, right? What kind of leadership do you want to see? How can we find some of the traits in us? Tomorrow, we will have a leadership expert breaking down the character of great leaders, whether it's a manager in an office or a country, and we'd like you to join that conversation. The lines will be open of what type of leadership do you think is important for this time we're in right now. Thanks for listening, folks. I'll catch you tomorrow.